The Department of Main Roads has planned a system of expressways for the Sydney metropolitan area, as shown on this map, to relieve the increasing vehicular congestion on principal thoroughfares. The Southern Expressway, the Southwestern Expressway, the Western Expressway, the Northwestern Expressway leading towards Newcastle, and the Ryde to Castlereagh Expressway travelling west through Blacktown. Of all these principal thoroughfares, the highest priority in construction was given to those which had as their origin the Sydney Harbour Bridge. First, the Kyle Expressway was completed, from the southern end of the Harbour Bridge to Woolloomooloo. Attention was next directed to the expressway from the northern end of the bridge, to be known as the Warringah Expressway. The planned route of this expressway passes through North Sydney to Cammeray, with an interchange at Narromburn where the Gore Hill Expressway joins it. Thence by a new bridge across Middle Harbour to Seaforth, where it will form two branches, going to Balgowlah in the east and towards French's Forest in the north. It was decided to construct the first 1.5 miles of this 9-mile expressway with the object of reducing the heavy volumes of traffic on the local street system of North Sydney, which by the early 1960s was nearing virtual saturation. DeLue Cather and Company, an American firm of engineering consultants, was engaged by the Department of Main Roads to conduct traffic studies and prepare plans and specifications for the first section of the Warringah Expressway. As soon as the route was established, the largest of all operations involving private property acquisition by the department got underway. The compensation paid to owners and tenants was of the order of $9 million. This figure represented a substantial portion of the total cost of the project. Some prominent North Sydney landmarks were among the 500 buildings which had to be demolished to make way for the expressway. By mid-1964, demolition work had advanced to the stage where preliminary construction could start. A contract was let to Teese Brothers Proprietary Limited to build drainage diversion structures and tunnels under future roadways to accommodate water, sewerage, gas and electricity services. The task of rearranging the public utility services on such a scale was one of great complexity, but nevertheless was executed without any significant interruption to consumer demands. With this preliminary work nearing completion, a contract was let to the firm of Reed and Stewart Proprietary Limited for the construction of the expressway. The construction program called for the building of the High Street overbridge at the outset. After the completion of the piers and abutments, tubular steel scaffolding was erected to enable the casting of concrete box girders. Simultaneously, the excavation of the rock cuttings over which the bridge structures at Mount Street were to span was proceeding. On completion of the piers and abutments of these structures, steel girders were transported to the site and erected. Unlike most civil engineering projects, the Warringah Expressway had to be built with traffic flowing through the construction area. This fact added considerably to the planning detail and to the cost of the work. In all, there were 15 major detours and over 50 minor detours of traffic in and around the construction site. These alterations in traffic pattern required the closest cooperation between the government departments responsible for traffic control. Giant bulldozers with hydraulic ripping attachments loosened former roadways and rock outcrops. Excavation of the sandstone cuttings on the expressway route necessitated the removal of 1.4 million cubic yards of rock. After ripping, the material was pushed into stockpiles and loaded into trucks for transport to other locations to form embankments. Not all rock could be loosened by ripping. Drilling and blasting was necessary for almost half the total. Drilling for the faces of the cuttings was closely spaced and had to be very accurate. After drilling and blasting with a light charge of explosives, a neat finish on the rock face was achieved. Construction of several retaining walls, totaling over 1 mile in length, was necessary in certain locations before excavated rock could be used for the formation of embankments. Embankments up to 65 feet in height were constructed with excavated rock material from the cuttings. Filling was placed in 8-inch layers and compacted with rolling equipment to an extremely high standard. It was essential to ensure this high degree of compaction, for in one location, the embankment provided the foundation for a high concrete retaining wall, nearly 1/4 mile long. Once embankments or cuttings had been brought to the correct level, drainage pipes were laid. Almost 5 miles of reinforced concrete pipes were installed to provide drainage system for the rapid disposal of stormwater collected on the roadways. By the spring of 1966, all 5 overbridges were in an advanced stage of construction. High Street, a reinforced concrete box girder structure. Mount Street, of steel girder design. Falcon Street, also of steel girder design, consists of two separate structures. A third steel girder bridge at Ernest Street consists of three separate structures. And at Miller Street, another bridge of the reinforced concrete box girder type. The northern toll barriers had to be replaced with temporary relocated units prior to the next stage of the project. Of all phases of construction, that which most intrigued the thousands of motorists who daily travel to the city was the demolition of the steel-arched tramway bridge. The removal of the bridge deck and its supports was an activity requiring great care in order to avoid damage to vehicles passing below. Removal of the twin arch ribs was the most delicate phase of the whole operation. After erection of the two supports in the traffic stream, the climax came by night in October 1966, when the centre segment of an arch rib was removed. The remaining portions of the arch ribs were dismantled on succeeding nights. At the same time, just south of this bridge, some of the spans of the 30-year-old concrete viaduct were demolished to make way for the new bridge approaches from the expressway. Special hydraulic jacks were used to fracture the concrete along a line of drill holes to create blocks of manageable size for disposal. Traffic continued on the ramp on the northern approach, whilst a new viaduct of pre-stressed concrete girder construction was erected. Part of the original concrete viaduct which was retained included 6 spans which did not suit the gradient of the new construction. Consequently, these spans had to be lowered by various amounts. Using specially designed equipment, this unusual operation was performed in several stages, lowering 6 44-foot spans by amounts up to nearly 7 feet. By the end of 1966, various parts of the project were beginning to fit together, and the expressway was taking shape. With the structural elements of the work well advanced, road pavements were commenced. First, a 12-inch thickness of specially selected sandstone filling was placed. Next, a thickness of 6 inches of fine crushed dolerite rock was laid down. On this layer, steel forms were set up to permit the placing of an 8-inch thick slab of concrete. These road forms were secured and carefully checked for line and level. The forms then acted as rails on which a paving train travelled. Firstly, a transverse travelling hopper was filled with concrete delivered by transit mixers. The hopper deposited a 4-inch thick layer of concrete in the forms. Steel reinforcing mesh was placed on this layer of concrete. The finishing unit of the train then spread, compacted and screeded the final 4 inches of concrete. Some hand finishing supplemented the machine finish. Contraction joints were provided in the concrete pavement at 25-foot intervals. Using the paving train, lengths of 12 feet wide roadway of the order of 1,700 lineal feet per day were laid. 2 inches of asphaltic concrete running surface were applied to the cement concrete. With the completion of the new viaduct to the Harbour Bridge in July 1967, traffic was transferred to it and the steel ramp adjoining was demolished. A second concrete viaduct was then built to widen the Harbour Bridge approach at the point where the expressway was to join it. By the end of 1967, much of the 270,000 square yards of concrete road paving had been laid, and all 5 overbridges were open to traffic. At Ridge Street, the final pre-stressed concrete girder of a footbridge was lifted into position. A distinctive appearance was given to the median areas by coloured concrete with a textured finish known as no fines concrete. For safe night driving, nearly 450 specially designed lighting standards with fiberglass outreaches carrying fluorescent mercury lamps were installed. With the completion of the concrete paving, asphalt paving continued at a greatly increased rate. Plastic reflectors and ceramic domes were provided to mark divisions between lanes and offered superior delineation by night and during periods of rain. Some hundreds of signs were erected on the expressway and approaches. These included international road signs. The largest of all the signs featured movable panels to suit reversible traffic flow in morning and evening peak periods. To supplement the movable sign legends, flexible plastic guideposts were devised to be inserted in the pavement prior to change of traffic flow. In preparation for the opening of the expressway, traffic maps were issued at toll barriers on Harbour Bridge approaches. The Warringah Expressway was opened to traffic on the 18th of June 1968, and His Excellency the Governor of New South Wales unveiled a plaque commemorating the occasion. Having opened the expressway as soon as practicable, the department set about honouring its undertaking to the public to blend the roadways with adjoining land and to make roadside planting a prominent feature. Three and a half years after the main work commenced, the Warringah Expressway fulfilled its planned objective in relieving congestion in the streets of North Sydney and adjacent suburbs, and increasing the capacity of the northern Sydney Harbour Bridge approaches. The expressway has 4 carriageways, providing for 8 lanes of traffic, with a climbing lane for slow-moving vehicles on the northbound outer carriageway. Traffic flow on the 2 centre lanes is reversible for the first mile and a quarter, permitting 3 carriageways to operate in the same direction during peak periods. Vehicles leave and join the expressway by ramps. The people of New South Wales can be proud of this expressway, which is undoubtedly of world standard.